everyone, I'm Heather, and I'm an OpenSciEd teacher and facilitator, and I'm excited to provide you with an overview of Lesson 2 of the Weather Unit. This lesson's amazing in a couple of ways. It allows students to immediately see that those questions that we wrote on our driving question board in Lesson 1 are immediately starting to be heard, and we're investigating them together like today. And it gives students an opportunity to analyze data that's both meaningful to them and helps them not only answer some of those questions that they had from Lesson 1, but inspires some new questions as well. So let's get into it. How did we get here? In Lesson 1, we figured out that there are always some key things happening along with hail, like wind, clouds, and rain. This hail stuff is frozen ice, frozen water or ice, and it's even happening when it's really warm outside. We think we know some of the causes of it, but we're really not sure positive, so we need to prove our claims with some evidence. So how do we do that? As we move into Lesson 2, we're really wondering what specific conditions are needed to make hail. So we kind of push on those ideas that are up on the driving question board. In the lesson at a glance, we notice that this is an investigation that takes 1.5 lessons or 1.5 days. It has about 20 minutes of prep, which is mostly copies. And it's not typical for a lesson to be 1.5 days. I'm going to show you where I might break it into 2 for you. Okay. But eventually you might be able to get down to that 1.5. There are 2 big sections of this lesson. The first piece is just looking at some of the hail pictures close up to make some notices and wonders about the hailstones themselves. They also look at a hail frequency map, and they notice that the hail doesn't all look exactly the same and that there are some places where it happens much more often than others. So we kind of want to push to know why. Why is it happening more frequently in those dark green areas that we see on the map and not the lighter areas? So as we move into the next section, we begin to navigate into some data from different hail events, and we look for some potential causes of hail that we brought up in Lesson 1 from our driving question board. They discover that there's definitely some patterns in the conditions for hail, and we come to a consensus later on in the lesson about those conditions, and we summarize those in our building understanding discussion. So what we figure out, we notice early on that the hail is made of layered ice and can often vary in size and shape. Some of them are kind of wicked looking. The hail events are all across the central U.S. for the most part. There are some pockets here and there, but most of it's in the central U.S. On days that have hail, we're noticing temperature changes or temperature somewhere between 50 and 90 degrees, which is still well above the freezing point of water, which is kind of weird. High humidity in the air, so somewhere between 36 and 97% is usually what's going on there. And then usually they happen later in the day and in warmer months. And they tend to affect a really small area of the map. They're not huge spread out storms. They're usually somewhere between 20 and 60 square miles, we're noticing. So some key moments in this lesson. In part 3, right after we look at some hail models, or not hail models, hail pictures, you'll get to look at this hail frequency map with students. And I like to come up to Scientist Circle for this because we can kind of gather around the map, and you can invite kids to come up and share their things that they notice and they wonder. They can jot those in their notebooks, and you can chart them down up on a chart paper as well. So as we notice these patterns of where these dark green spots are on the map, we're like also starting to wonder, wait a second, what are the conditions there then? How come it's happening over here and not over there? What are the conditions needed for hail? So we decide we need to see some more data. So by the end of the class, we're going to take a look at one sample set of data just for one location, just to kind of familiarize them with what kinds of information is on this, because it's a lot of numbers to look at, like holy cow. So how can we break this apart and like really figure out what this is we're looking at? So we talk about like, okay, we can see the temperature and maybe look at how the temperature changes throughout the day. We can look at the humidity, like what's the range of humidity. We notice that it tells when the hail happened on that map piece. It also tells us like if there was any big shifts in the wind or any strong winds, how strong were they, and even the size of the hailstone. So those are some things that we can look for, and we can model a strategy called the I-squared strategy, where they look for something that they see in the data and annotate something that it means. So I would have a copy of this for each student, have the map as well as the data, like a front and back copy, where they could annotate something like what I see and what it means, maybe on just the map itself. And then on the data itself, map of what I see and what it means. And that's something that maybe you can collect from them as an exit ticket. There's also this cool option for an exit ticket here, which depends on where you are with timing. If you had a moment, if you had enough time where you could, after doing the group analysis of that original case study, and you wanted to pass out, here's your partner stuff for tomorrow, and have them take a quick look at it. You could give them an exit ticket there, or you could change this and make that your exit ticket for tomorrow. I love that our slides are editable, so we can move them around and change them and revise those questions for an exit ticket opportunity if you needed to. But for me, I might do this on the end of the next day here, where we have analyzed data together. So after students have had a chance to get together with their partner on day 2, and they get another case, here's your location. You and your partner look for some things that you notice about the temperature or the humidity, the time of day. Look for some of these things specifically. The wind. Does it cover a big area or a small area? Like how many square miles approximately is it? Look at your map. So have them look for those big things. And maybe do at least one what I see and what it means, if not circling and maybe annotating some of those key things on that list. And then invite them to come up to the science circle again after about 10 minutes or so. And we're going to make a chart that looks similar to what you see up here. We're going to invite group by group them to share their key findings about those specific conditions like temperature, humidity, et cetera. And what we'll start to notice over time is, like, as we get them all shared out, we're going to see some patterns. We're going to notice some things about like when during the day it happens, or, how much does the temperature vary? There are going to be some things that they notice, and you can invite them to come up and point, or tag them with a sticky note, all kinds of ways that you can do that make it like interactive and can get the kids up and moving and sharing what they see and what they think it means. Again, an exit ticket at the end of that would be pretty ideal as well. Again, you can move that slide and have that there as an indicator at the end as well. So where do we go from here? We notice that the hail forms in warmer times of the year when temperatures are well above freezing. So that's just kind of weird. And we have some ideas about the wind might be pushing the stuff up, might be pushing the water up and making it freeze. But how do we prove that it's colder up there than it is down here? Like, some people still have that misconception that it's warmer up high. So how do we prove it to those folks that it is actually colder the higher up you go? Because some people don't have that experience. So I might even show them a picture of this weather balloon here and ask, does anyone know what that is? Somebody in class probably is going to say, oh, that might be a weather balloon. Yeah, what does a weather balloon do? Well, it collects data from up high. Cool. So would you guys like me to collect some data for you guys from weather balloons to see like what's going on at some of these locations above the ground? Sweet. I'll have that for you guys tomorrow. So we've already navigated to like having them want to see that data. And if you're really cool about it, you could do the computer science edition, which is to add, make your own weather balloon and use a sensor to send up and get some fun data from above, even above the ground at your school. Material management tips and tricks here. Again, like I mentioned earlier, use your driving question board and your chart papers as navigation tools to point out the questions that they've already asked and use those as a nudge forward to the next thing. Know exactly where you need them to go and what you need to think about ahead of time, and you can think about questions you need to ask to point them that direction. Some tips and tricks again: use a timer to keep within your time constraints. Keep the timer visible to students so they know that they have a limit on their time as well. And practice using that I-squared method, not just today, but continue using it in lessons to come, and share it with colleagues. Some words in here that we earn hailstone in lesson 2, but the other words that we encounter like humidity and weather conditions, you can kind of add those up if you feel the need. I always leave my driving question board and investigation ideas up all the time to use for navigation, but those other chart papers, you might want to think about having a hiding place in your room for those charts and only pulling them out as needed. There's some really creative ideas on the Facebook groups for managing all of those posters and chart papers, so check that out. And again, just to wrap things up, my students really love this lesson because not only did it answer some of their questions, but it helped them build their confidence and their ability to analyze data and leaves them excited for that next lesson about the weather balloon. So I hope this helps you guys out planning for your first attempt at this lesson, and I will see you on the next video.